today's last day with limits at infinity. We're going to use the graphing calculator a lot, so you want to have yours available. The first thing we're going to do is type this into our graphing calculator and label any of the extreme or asymptotes that exist. We're not going to compute this by hand right now. We'll go ahead and just look at the graphing calculator. I've went ahead and put that in the graphing calculator. As you can see, if I go ahead and look at this graph just a little bit more in detail, I've already punched it in the calculator. I can trace it, and when I start tracing it, you'll notice that the x and y coordinates are changing. And this one looks of interest to me because it looks to be an extrema, which it is. If we look here a little bit closer, it looks like at 0, I can't get exactly on it, it will be equal to 1. It was on it for a second. So this would be our maximum value. So I'll go back and I'll put that onto our slide. So we have an extrema. We have a relative max at 0, 1. I'll go back to the graph here, and if I look at this a little bit further, my y values are going down, 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 and they still are decreasing right now, and about right here they start increasing. So they were at 0.32, negative 3.2, and then negative 0.33, and then negative 0.333, and then they start going back up. So it looks like to be about negative 2, negative 2 comma negative 1/3. So relative minimum at negative 2 comma negative 1/3. Now the other way we'd have to do this is by computing our first derivative and then finding our critical numbers. We would find them to be this 0 and negative 2, and then we would plug those back in and get those other values. So we do have relative extrema. Now the asymptotes that exist looks to be like the only asymptote, if I go out here a little bit further, is that it's getting closer and closer to 0 as it approaches negative infinity. And if I go back out the other way, it would be getting closer and closer to 0 on the other side as well. And you can check that out on your graphing calculator. So that means that there is a horizontal asymptote at y equals 0. This is all we were doing on this problem, was just looking at it with a graphing calculator. Going on, we're going to use the graphing calculator again. This time I'm not going to enter those into the graphing calculator I have on mine. We'll just go ahead and do this algebraically on this slide. You guys can use your graphing calculator to show that f and g are the same. What I will do is go ahead and show you why they are the same. So what I'm going to do is I'm going to rewrite f of x, and I'm going to rewrite it, and I'm going to divide each of these off. So I have a negative x cubed over 2x squared, and then this negative actually goes all the way through here. I'm going to make sure I distribute it. So I have a positive 2x squared over 2x squared, and then I have a negative 2 over 2x squared. So if I simplify this and I reduce some of my x's here, I have a negative x over 2 plus, that just ends up being 1, and my 2's cancel here, so I have a minus 1 over x squared. Now while these don't look identical, they are, because this actually means 1/2 x. If you were to look at your graphing calculator, you will also see that those are the exact same.